Wabarakatuh. Okay, now I will show you this to solve the linear equation using Gauss elimination method with partial pivoting. So I assume in this equation I use 4 decimal places. So they're given the linear equalities. So we convert it into the matrix form, which A times S equal to B, like this. After that, we must put it in the table which have the factor table, the A table which is matrix A, B here, and then the ERO for exchange the matrix form. So we must make sure to use Gauss elimination method. We must make sure that the low diagonal, triangular diagonal must be value to 0. So first of all, we must make sure this first pivot must be the maximum value in this column here. So this is the lowest value, so it cannot so we must change it. Let's change it with row 3. So row 3, we change it, and then we get the new matrix here, and the first pivot follow the rule, which is the maximum above the column. So after that, we have check it. We must find the factor M21 and M31. This factor is to make sure that the A21 value and A31 value must equal to 0. So M21 here is 2 divided by 3, which is the formula is A21 over A11. Also same here, A31 divided by A11. So we must make sure it is below 1. If it's not below than 1, we must also change this metric to get this factor below than 1. So after that, we have find the factor. We must put in this formula. So this all row 2 must follow this equation, which is row 2, this 2, minus this M21 factor. We have find it 2 over 3, multiply with the R1 3. So we get 0 here, right below. So also same with row 3, using this formula, also we get here. So after we are using this ARO, we get the 2 value here is 0, but we forgot that here is not equal to 0, so we also must check again. So in this, to make sure this value equal to 0, we must make sure that this pivot is maximum over this value. So this is smaller than this, so we must change the row. So let's change the row with row 2 with row 3, and then we get here 1.667 up and 0.33 down. All this line must exchange according to this ERO. So after that, we have make sure this is the maximum value. So as usual, we follow this equation, 0.333 divided by 1.667 to get the factor must be modulus. So we get lower than 1. So it passed to use the factor, and then we make this ERO equation, which is all our row 3 follow this equation. So row 3 divided by factor M32 times row 2. So like this, 0.333 minus with the factor times 1.667, so we get 0 here. So this metric follow the low triangular diagonal matrix, so 0 0 here. And after that, we use this backward substitution to get each x1, x2, x3 value. So we use the below equation here, so we get x3 4. So we go through to this second row. This second row, we get this equation, and then we get x2 equal to 1.999. Make sure it is 4 decimal place. And after that, we use the first row equation, and this is the equation, and then we get x1 equal to 1.0001. So hence we get the x1, x2, x3 value here. After that, we must find the r value. So r value, this provide the equation b minus a times x bar. So b here we use the actual value of b, like this 3, 0, 15. And also same with the metric a, we use the initial one, and then x bar we just use this value, and then we put it in calculator, we get this value. So for the r value, we must find the maximum residual here. So we find that 0.002 is the maximum value. So that's all. Thank you.